So exponential decay, by definition, is an amount or quantity or weight, price. It's an amount that decreases at a rate over a specific time. It's an amount that decreases at a rate over a specific time. So, like, you're a doctor and you're prescribing an antibiotic because your patient is sick, or a pharmacist. You have to know when they take that medicine in their body is going to decrease at a certain rate over a certain time. So how often do they need to take the medicine? If they take it too soon together, they're going to have too much of the medicine in their body. So you have to, there's a scientific, a mathematical way of figuring that out. City planners use this. Is the population of a town decreasing? Are people moving out? Well, there's a scientific way to figure out in 10 years what will the population of your city be. Should you build a new school? Well, let's mathematically figure out how many people are going to be here. So exponential decay has a formula, just like what we had yesterday. And Angelina was right. It's basically, instead of adding, we're going to subtract. So y equals, y is our answer, a, which stands for the amount that we begin with, 1 minus the rate to the power of t. And yesterday, our exponential growth, we did basic interest was a times the quantity 1 plus the rate to the power of t. So today, since it's decay, we're decreasing. This is just t. This is basic. Yep, this is basic decay. So y is the answer. A is the amount. R is the rate. And T is time. And again, you get to write a word problem. Example. The population is decreasing at a rate of 1% per year. In 2000, there were, how many? 13,000 people. How many people in 2008. So let's substitute. What goes where? In the formula, y equals 1, nope, a 1 minus r to the power of t. What goes where? 13,000 is my population, so that's my amount. 1 minus, what's my rate? Yeah, it's 1%, but I can't put 1, correct? I have to put it as a decimal, a percent value. And what's my time frame? 8 years. So the hardest part is substituting. Oops, one too many zeros. 13,000 times 1 minus 0.01 to the power of 8. I write down 11995.68103. Well, I mean, that's what my calculator says, but what does that answer mean? That's what I get. Yesterday, we would have rounded, we would have said 0.68, correct? But yesterday, we were talking money. Are we talking about money today? What are we talking about? People. So I have to round to the nearest whole because I'm talking to people. I can't have 0.6 of a person. That's not the way that the census works. Not 5, but 6 people. Again, because we don't have parts of people. You have to have whole number of people. Six. It was a 5. I made it a 6. So really, again, it's just simplifying. It's identifying the amount, the rate, and the time. Being able to identify those 3 variables and substituting them into a formula. So there's another formula. The next formula is called a half-life. And you will use the half-life formula when it says the half-life of blank. Just like yesterday you used compound interest when it said compound in the word problem. So half-life is used to predict the rate of decay in a substance. You want to be a police officer, you understand half-life. You want to be a doctor or a pharmacist or a nurse, you understand half-life. You want to be a chemist, you understand half-life. Half-life is applicable to lots of jobs. Okay, half-life, here's the formula. A equals P 0.5. Why 0.5? What does that represent? Half. You could put a fraction of a half there. To the power of t. We don't have to mess with this middle part because we know it's going to half itself. That's the way this substance works. So again, A is the answer. If you want to put Y, because we used Y up here, that's fine. P is the original amount. And T is time. But there's a little bit more math to it. Oh wait, here we go. We're going to, example, find the amount of fluorine, which is a element, and it's really fluorine 20, if you want to get specific. What? Yeah. Flourile. In a 40-gram sample, so does this 20 have to go into the formula, or is this 20 part of the name? The 20 is part of the name, so don't get confused by that. After 2.2 minutes. Now, life would be great if that's all we needed to know. But when we mess with half-lives, I have to know what the scientific time conversion is. I can't just take 2.2 minutes and put it into time. That's not the way that half-life works. So you also have to know, they have to give you the information that fluorine 20 has a half-life of 11 seconds. That means every 11 seconds, fluorine 20 decreases by half. So if there were 100, in 11 seconds there'd be 50. And 11 seconds later, there'd be 25. So half-life requires some conversion. In order to do half-life, I'm going to put some directions over here. I have to convert time. Maybe. Maybe not, but most of the time I have to convert time. Then I substitute. So I know that 2.2 minutes, and what's my other amount of time? 11 seconds. I have to convert that time. So I have to know 2.2 minutes. I have to know how many groups of 11 seconds fit into 2.2 minutes. So first I'm going to take 2.2 minutes and I'm going to multiply it by 60. Why? Because I'm taking minutes and I'm changing it to seconds. I have to convert my time. I want seconds, but they give me minutes. So I have to take 2.2 minutes and multiply by 60. And what do I get? 132 what? Seconds. I have to convert my time. But I'm not going to substitute 132 seconds. I know that the half-life, a life cycle basically, is 11 seconds. So I want to know T for time, how many half-lives do I have? So what am I going to do now? Divide it by 11 seconds. So what's 132 divided by 11? What? Use a calculator. 12. So 12 is my time. So again, to use half-life, we have to get our time converted. They give me 2.2 minutes, but I know the half-life is 11 seconds. So I take 2.2 times 60, because I want to take minutes into seconds. Then I'm going to divide by 11 seconds. And I get 12. So now I can substitute. My formula was A equals the amount times half to the power of T. What's the amount of fluorine 20 I start with? 40 grams times 0.5. And what's my time frame? 12. After 2.2 minutes, I start out with 40 grams. That's 40 paper clips, right? A gram is about a paper clip. After 2.2 minutes, how many grams are left? 40, 0.5 to the power of 12. 0.009765625. How would I write that? I can't make it 0 because it's technically not 0. So what should I do? Angelina? 1. Because I'm rounding, right? That 9 tells me to make that 0 a 1. So I went from 40 paper clips to 1/100th of a paper clip in 2.2 minutes. So again, to use half-life, you need to convert your time. Then we can substitute to find our answer. Yesterday, all of our answers increased. They got larger. Today, all of our answers are going to decrease. They're going to get smaller.